Hola, ¿qué tal? Bienvenidos a esta sesión. Mi nombre es Franco Ramos y yo seré su host el día de hoy. Primero que nada, pues muchas gracias por tomarse el tiempo para asistir a esta sesión. Para nosotros es un gusto estar aquí y poder platicar el día de hoy de temas de simulación y cómo esto puede ayudarles en su proceso de desarrollo típico de productos. Algunas consideraciones que me gustaría comentarles al inicio de esta sesión. Ayúdenos manteniendo sus micrófonos en silencio para evitar cualquier problema de comunicación. Encender la cámara web para tener una mejor experiencia en el momento en el que haya una interacción. Y si tienen alguna pregunta, por favor, no duden en levantar la mano o ayudarnos escribiéndonos en el chat. Tenemos todo un equipo que nos estará ayudando y soportando para poder contestar cualquier cuestión y poder hacer de esta sesión una sesión efectiva. Para esta sesión vamos a tener los siguientes speakers. May Taylor, nuestra experta en simulación y gemelo digital de Siemens, a quien agradezco mucho su tiempo. Tenemos a Ricardo Morales, especialista en Supplier Quality and Development de General Motors México, y Aaron González, director general de Goaltech, uno de nuestros socios tecnológicos, quienes nos ayudarán en base a la siguiente agenda a irles transmitiendo los beneficios de valor y poder explicarles cómo funciona nuestro portafolio de soluciones. Esta es la agenda que vamos a llevar de manera muy rápida. Tenemos una breve introducción seguida de las palabras de Ricardo Morales de GM, cómo están atacando la simulación, cuál es la importancia de utilizar este tipo de tecnologías. Posteriormente, Aaron González nos presentará Goaltech, cuáles son sus valores agregados como socio tecnológico de Siemens, y finalmente tendremos pues la presentación de todo el portafolio de simulación, en donde veremos muchos temas muy importantes para cerrar con una sesión de preguntas y respuestas. Como les comenté, en cualquier momento pueden ustedes apoyarnos con sus preguntas en el chat e iremos contestándolas, y al final pues haremos una sesión ya de interacción para poder atacar cualquier cuestión. Sin más, pues bueno, Ricardo Morales, ingeniero Ricardo, agradezco mucho tu tiempo, y si me ayudas a presentar los beneficios, una justificación de por qué es importante utilizar este tipo de tecnologías hoy en día.
Hola, ¿qué tal? Buenos días a todos. Muchísimas gracias por la invitación. Siempre me da muchísimo gusto platicar de los beneficios de lo que son las nuevas tecnologías. Por ahí Franco comentó que efectivamente soy business planner del área de calidad de proveedores a nivel nacional. Pero no solo eso, de hecho tengo 8 años de experiencia como ingeniero de análisis, sobre todo en el área de ingeniería estructural y crashworthiness. De hecho, me ha tocado participar en muchísimos proyectos y siempre lo he dicho, uno de los roles que más he disfrutado en la compañía pues ha sido este. Y por eso me da muchísimo gusto platicarles de cómo es que General Motors se ha involucrado en todo lo que son las tecnologías de CAE. Y si me ayudas con la siguiente slide, Franco, pues yo creo que en una industria pujante, dinámica como es la industria automotriz, pues siempre tenemos que buscar resolver todos los retos lo más temprano en las etapas de desarrollo del producto. Y la verdad es que no hay mejor forma de hacerlo que es a través de las tecnologías de análisis virtual, como son CAE. Y esto pues, simplemente pues, porque en la industria cada vez tenemos regulaciones más rigurosas, y no solo en cuanto a compliance de regulaciones, también tenemos que asegurarnos de que nuestros vehículos pues, sean financieramente factibles, que cada vehículo tenga un EBIT que le permita a la compañía operar eficientemente. Y pues obviamente al hablar de integración y desarrollo de soluciones, pues CAE nos permite poder alcanzar y identificar problemas lo más temprano posible. Además, pues nos permite también manejar y gestionar muy bien la complejidad. Ya lo he comentado aquí en varios webinars, cada vez más enfrentamos más retos en cuanto a la integración de arquitecturas eléctricas, en cuanto a la integración de soluciones, debido a que pues la industria se está moviendo hacia la electrificación y nos estamos moviendo hacia los vehículos autónomos. Entonces cada vez estamos más confiando en lo que es integración de software e integración de arquitecturas, arneses, circuitos eléctricos. Y esto la verdad es que siempre va a ser un reto en el aspecto en cómo gestionamos todo este amplio complejidad de números de parte. Cuando nosotros nos vamos y nos paramos a una planta con un arnesero, pues vemos que tenemos pues cientos de números de parte con los cuales cada proveedor tiene que estar lidiando. Y la verdad es que no es fácil. Y nosotros también tenemos que apoyar esa parte, ayudándole a nuestra cadena de suministro a gestionar este tipo de problemas. Y además, pues obviamente, todos los requerimientos de desempeño de nuestros clientes los podemos monitorear de manera más sencilla a través de estas tecnologías. Si me ayudas con la siguiente slide, Franco, por favor. Pues la verdad es que desde que soy parte de esta industria y sobre todo en General Motors, la verdad es que nos enorgullecemos en la forma en que hemos hecho uso de las herramientas de CAE. Tanto yo les platiqué que pues, principalmente me he involucrado en análisis estructural, crashworthiness, pero la verdad es que hay muchísimas soluciones disponibles también en el aspecto de CFD, aero, análisis térmico. Y eso también nos permite traer soluciones lo más pronto posible. La verdad es que muchísimos de los retos que enfrentamos a la hora de realizar simulaciones es pues realmente qué información tenemos disponible, ¿no? Cada compañía, cada organización tiene que asegurarse de tener la infraestructura sus bases de datos alimentadas dependiendo de la información que vayamos a utilizar, ¿no? Por ejemplo, últimamente General Motors ha invertido muchísimo en entender cómo se comportan los materiales en fatiga, en vibración, y hay información de materiales pues, que hemos tenido que desarrollar con el tiempo. Y este esfuerzo ha sido bastante interesante. Hemos involucrado a varias universidades, hemos involucrado a varias otras organizaciones. Y eso también permite la integración y la sinergia de conocimiento con otras áreas, ¿no? Entonces, lo que nos podemos dar cuenta una vez que nos involucramos en implementar este tipo de soluciones, no se detiene. Constantemente nos damos cuenta de los beneficios que va teniendo estas tecnologías y obviamente nosotros mismos vamos exigiendo más información y vamos creciendo. La verdad es que ahorita hemos crecido toda nuestra infraestructura de análisis. Tenemos organizaciones de CAE en Estados Unidos, en México, en Sudamérica, en India, en China, en Corea, y creo que esto no va a detener. Todas las áreas están creciendo y creo que cada vez más GM va a tratar de moverse hacia el lado izquierdo en cuanto al desarrollo de productos, ¿no? Al lado izquierdo me refiero a lo más temprano posible en el tiempo de evolución del desarrollo. Y pues espero que esta introducción nos ayude a entender pues cómo General Motors está enfrentando estos retos. La verdad es que podría pasarme aquí una hora hablando de esto y creo que no terminaría, pero pues creo que quisiera permitir que nuestros expertos de Siemens y obviamente también nuestros socios de Goaltech, pues también hablen un poco más al respecto, ¿no? Muchísimas gracias a todos. Gracias, Franco.
Muchas gracias, Ricardo. Y bueno, sin duda, lo que mencionas es importante tener ya esta tecnología. Y también comentarles que esta es una serie de webinars en conjunto, GM, Siemens, para poderles llevar a ustedes los beneficios de valor, no nada más en este momento de simulación, e iremos llevando pues cada uno de los productos y soluciones. Entonces vamos a ir haciéndoles llegar las invitaciones para que puedan acompañarnos. Ahora voy a pedirle a Aarón que nos ayude a presentar su compañía Goaltech, nuestro socio de negocio. Aarón.
Muchas gracias, Franco, y muchísimas gracias a todos los que nos están viendo en este webinar. Me da mucho gusto estar aquí con ustedes y me da mucho gusto el poder tener esta plática que nos va a ayudar nuestro panelista principal, que es May, para hablar sobre los beneficios de la simulación y todo lo que ahora puede aportar Siemens y nosotros como Goaltech, como aliado de Siemens para para que ustedes tengan un conocimiento más amplio de todas las soluciones y beneficios de la simulación. Como ya bien dijo Ricardo, es un campo inmenso que podríamos platicar sobre él durante largo tiempo, durante más de una hora, como él lo dijo fácilmente. Les comento de mi parte que pues tengo ya cerca de 20 años previo a esta aventura de Goaltech, cerca de 20 años en industria de investigación y desarrollo para corporativos internacionales, y pues hablando de cómo ha evolucionado estas herramientas de simulación es enorme, ¿verdad? Desde finales del siglo pasado, que fue cuando inicié mi carrera laboral, que empezamos a utilizar las herramientas de simulación, pues eran mucho más básicas. Ahora el portafolio ha crecido enormemente. Hay infinidad de soluciones que les pueden ayudar para sus problemas específicos, y pues cada vez son más poderosas las herramientas para poder detallar mejor los fenómenos que ustedes quieren analizar, ¿verdad? Ya sea fenómenos físicos, de ingeniería o procesos industriales. Entonces, en gran parte de los procesos y de las soluciones que tenemos va a haber algo específico que los va a poder ayudar. Antes de pasar y darle la palabra a May, rápidamente en un par de minutos quiero presentarles nuestra empresa. Somos socio comercial de Siemens desde hace más de 10 años. Estamos en todo el país, tenemos presencia en todo el país, clientes en todo el país prácticamente, y pues con oficinas estratégicamente colocadas en el norte y en Bajío para apoyarlos. Por los últimos 3 años hemos sido afortunados en ser reconocidos como el canal o el partner del año para las soluciones de Siemens Industry Software en la región de Mesoamérica, que incluye el Caribe, México y Centroamérica. Y pues muy contentos de decir que más del 90% de nuestros clientes vuelven con nosotros y seguimos trabajando en volver a crecer los proyectos. Cada vez vemos temas más complejos, pero muy apasionantes para apoyar a nuestros clientes. Si me ayudas, Franco. Nuestra principal alianza es con Siemens Industry Software, pero también tenemos otras alianzas para ayudar a la digitalización y a crear los gemelos digitales para sus empresas. Tenemos algunas marcas de representación de escáneres en 3D y de impresoras en 3D o manufactura aditiva, como lo son Artec, 3D Systems y Creaform. Pero sí, una de nuestras principales marcas de representación es Siemens, con las soluciones de CAD, de maquinado de CAM, de análisis y de administración de información o PLM. Adelante, Franco. Entonces, ¿cómo les podemos ayudar? Pues realmente tenemos las soluciones para ustedes, tanto en las herramientas de software o hardware para digitalización, para sus gemelos digitales, pero también los podemos apoyar con muchos de los servicios relacionados a estas áreas, ¿verdad? Les podemos ayudar con sus proyectos de ingeniería en CAD, en CAE, con impresión 3D, con ingeniería inversa, entrenamiento o soporte para proyectos. Es una gran variedad de los servicios que podemos ofrecer en estas áreas, y pues muchas de las capacidades que tenemos para soportarlos en cualquiera que sea su necesidad, y que nos inviten a apoyarlos. Sin más, quiero presentar ahora a May. Voy a cambiar a inglés. Esta presentación de aquí en adelante va a ser en inglés. Nos va a estar ayudando May Taylor. May, welcome and thank you for joining this webinar. And from here on, I'd like you to take the microphone and start presenting to us what Simcenter can do for us.
Thank you very much. Hopefully everyone can see my screen. Let me hide. Okay. Can everybody see and hear me?
Yes.
Yes, May. Go ahead.
All right, wonderful. Thank you all for joining today. Here is the agenda. I just really want to discuss simulation-driven design. I'm very excited about it. The Siemens offerings, and specifically what advantages we have, and our product Simcenter 3D, what the value really is. So let's just kick it off with, why do you need simulation-driven design? As many of you know, manufacturers today face many of the same challenges to stay competitive. There are bottlenecks in the development process that cause folks to make decisions way too late in the development cycle. Manufacturers are always looking for ways to cut costs and increase the bottom line. In the competitive environment we all live in, product developers are constantly looking for ways to decrease time to market, so you can introduce new products before your competition. There's also continuous pressure to create a stream of new products of increasing complexity and functionality. And finally, there's always the need to reduce warranty costs. So, especially in the automotive industry, there's an increasing product development complexity driven by smart products, new materials, and manufacturing methods, and increased customization. So all of this has an implication that current practices appear to be inadequate to meet new demands. More unknowns imply longer lead times and a greater risk that products will not perform as intended, leading to lost opportunities and dissatisfied customers. Some more specific trends in the automotive industry are drastic safety standards and regulations. So as a consequence, data traceability and data management are critical items to be successful in certifying a car. Second, the increasing pressure to design the next car faster, reducing development cycles. As such, the need for efficient CAE workflows and processes. Third, expensive time-consuming physical testing that's slowing down the development cycle. Now, this is what pushed the industry to use CAE in the first place, but as a result, there's intensive use of multiple CAE solutions that are disconnected. And then finally, a push for increased fuel efficiency and without compromising passenger comfort. And this is pushing for the use of such things as composites, optimization, and CAE has to follow suit. So when you consider the benefits and challenges of simulation as it was traditionally used, it's reduced the need for physical prototypes, and it's greatly reduced development costs. But traditional simulation still has challenges. It's been a complex multi-tool process requiring experts in each of the physics domains. It's also an iterative process between designers and analysts. And there's usually far more designers than analysts, so there's a lot of back and forth that goes on. And many times the CAE team becomes overwhelmed. So how do we change that? Historically, there's been a wall between design and simulation. And this is one of the main reasons why the simulation process takes a long time. So as I just stated, traditional simulation is a bottleneck. There is a first iteration of a design that's typically handed off to the simulation team that's using a disconnected analysis software tool. And then many times what happens is the design continues to change while the analyst is working on the first design. And then by the time the results come back, they're already out of date and out of sync with the latest design. So many times it might be that the design even gets released before the development organization is fully confident it can meet performance requirements. And then you're not really sure if the design is actually going to meet the requirements. Well, but the good news is that the age of simulation-driven design is here today, and it offers many advantages for your company. How is it even a possibility? Well, to enable it, we must first remove the wall between design and simulation. And then simulation and design must be integrated into a common platform. Design data is no longer thrown over the wall, but instead seamlessly passes to the simulation tools without translation. In this new paradigm, the underlying simulation technology scales across the entire concept, design, and validation chain. This means your results are consistent, throughout the development process. In a survey report that was conducted by the Aberdeen Group, they found that 73% of best-in-class organizations are using simulation as part of their detailed design processes today. And this has helped organizations using simulation-driven design to reduce their development time by 29%, as well as deliver products that are more likely to work the first time. So, simulation-driven design helps you essentially shift your development processes further left. With simulation-driven design, you can actually start the design process by using simulation first. That actually helps define what the initial design shape will be. And then you can continuously perform a simple qualitative simulation on each design iteration to make sure the design's on the right track and thereby beat your competition. So the whole idea is to keep your design in sync with your simulation. Now, the benefits are many. I've just shown a few here. Basically, the ability to discover new, unimagined design possibilities. I mean, normally what happens is when folks go into design, they just based it on last year's model or what they're used to designing. When you use simulation, that's no longer the case. Also, the ability to increase design confidence while increasing speed to design release. So you're actually analyzing the product before it goes out the door. So, but you might be wondering how your design team is going to be able to perform simulation. You might have heard some of these concerns and objections in your own office. So, because in the past, learning simulation generally required the learning of at least one new interface or perhaps several. Even preparing a model for solving can involve multiple steps in applications. However, with Simcenter 3D, which is what I'm going to show you today, this is no longer the case. So to help overcome these challenges and barriers, we made the simulation processes more accessible to designers. Simulation needs to be placed in the same CAD environment that the designer is already familiar with. This helps lower the training barrier for pure software operation. Secondly, simulation-driven design actually requires a tighter collaboration between the designer and the analysis team. The CAE team's knowledge and experience is still highly valuable. With the right tools, the simulation team can share and leverage that knowledge by helping to guide designers with the correct processes to perform routine simulation tasks. So in this new age, we remove the wall between simulation and design by using a common platform. Design data is not thrown over the wall, but passes directly to the simulation tools without translation. So that's why companies are now turning to Siemens. Simulation-driven design is achieved through the combination of NX and Simcenter simulation technology. Both NX CAD and Simcenter 3D and Flow Efd products are based on the NX platform, which means designers and simulation experts can easily share data and technology. Simulation can be exposed to the design team directly in the NX CAD environment for both conceptual design and detailed design work. And simulation experts can have confidence in the results created by the design team since they're using the same fundamental technology. And they can even have control over the types of simulations that are run by the design team. So now let's move on. What are our specific offerings for simulation-driven design? So as we create our products, we go out, we ask our customers what they're looking for. And what we've determined is most want a pervasive design exploration environment and also be managed. You need to manage the data. So, and they also want tools to go from designer through the analyst all the way to the specialist, span the entire spectrum. And we have accomplished that And we offer products that are guided, design-centric, automated, and a full environment. So what do we mean by each of these? So let's look at them. What do we mean by guided? What we mean by guided is we have what we call wizards, and we have 3 of them that come out of the box: a vibration wizard, a stress wizard, and a durability wizard. And basically what these are for people that have really no knowledge of how to do finite analysis. So it actually steps you through the process. So as you can see here, here's the simulation wizard, the durability, the stress, and the vibration. So the example they're showing here is a vibration wizard, which allows you to extract the normal modes for a particular component or assembly so that you can understand its vibration characteristics. But as you can see here, it steps you through it. You pick the part, you pick where it's constrained, in other words, where are you holding down the piece, and then also choose your material. And then it's also intelligent enough to give you the best element size and mesh it. And then you simply run the analysis. And you're using Simcenter Nastran, so you're using the same analysis solver that analysts would be using. And then here you're looking at the post-processing of all the different normal modes. And again, it's just stepping you right through it. It's very easy, and pretty much anyone can do it. And then on top of that, it allows you to automatically create a report that you could provide back to your analysis group and or your manager or your director. And it does it automatically. And it encapsulates all the material, all the information that was used in your analysis. So it makes it very simple to step through the process. So the next step up would be the design-centric capability. And basically what that is a scaled down version of the menuing system. It restricts the type of analyses that you can do, and also the types of element types that you can pick. So it makes it easier and simple, but it does not step you through the process. So it assumes that you have some knowledge of how to perform a simulation. Also, we have Simcenter Flow Efd, which is an excellent CFD choice for designers. It's fully embedded in CAD. It's an intuitive experience, intelligent technology, proven ROI. This is also designed for the designer level. And then let's go to the third, the automated. And what this means is you can use things such as NX Open, which allows you to automate a very complex task. And what you can do is actually create your own steps. So if you look up here, steps 1 through 5, these are specific to this particular analysis, which is doing a CFD analysis through a manifold. And you actually create your own steps. And so therefore, very complex analyses that only an analyst would do, you can make it such that the designers can simply follow through these 5 steps and actually execute the analyses. And then finally, the full environment, which is for your high-end analyst. And that is really the power really of Simcenter 3D. What you see here on the right is all the different solvers are surrounding the engineering desktop. And this really is all the capability that you can achieve in Simcenter 3D. And what's extremely valuable is that all of this is an integrated environment. It used to be that you had to go to a different tool for each of these capabilities from a solver perspective. And we've now put it and integrated it into Simcenter 3D. Now, particular to the automotive industry, structure, composites, dynamics, those are the classics. Motion is another playground for Simcenter 3D. The simulation of mechanisms, model phenomenon like opening and closing doors, roofs, trunks. We offer both interior and exterior acoustics, thermal and flow. For example, simulation of powertrain underhood cooling. We also offer simulation of hoses and cables. And then finally, multi-physics capabilities of Simcenter 3D allow you to analyze cabin comfort, HVAC performances. So really, what I want you to take away from this slide is we have a wide range of capability in our solvers. So specific advantages, basically usability, automation, and scalability, which we've talked briefly about already. The usability is that you can actually configure Simcenter 3D based on the role that the person is. For example, the designer, you may want to restrict him or her to particular element types or analyses. And then the analyst, of course, would have a full-blown access to everything. And then the reviewer, that person may only want to go in and be able to set the results and look at them. And it's very easy to do this. It streamlines the processes and flattens the learning curve. The other big advantage is you're associative. Your analysis model is associated to your geometry model. And this is big because it allows you to use the power of the geometry tools that are inside of NX-CAD, namely Synchronous Technology, which allows you to do what-if studies very, very quickly since you're associated to the simulation model. And I'll just run this very quickly. I know we're wanting, I'm interested in keeping us within this certain time limit. But basically, this particular part lends itself to be a thin-walled structure. And I'll show you how that's accomplished. But as an analyst, you want to be able to very quickly go in there and remove all the blends and chamfers because typically those are not important when you do an analysis. And this gives you the ability to do that very quickly because in Simcenter 3D, you have all the geometry capabilities of NX-CAD. So this is showing you actually how to extract a midsurface. And the really powerful thing is this midsurface is tied directly back to the 3D model so that if the 3D model changes, the midsurface will automatically change. And that's showing you all the different solver environments that I'll go into in the next slide. So we have extracted the midsurface. The next thing you do is you mesh it with plates or shells, and you can either assign your own thickness or you can extract it from the geometry, which is what this is doing. So the thickness associated with the shell elements are extracted directly from the geometry, which is extremely important in case it changes. Now, using synchronous technology, you can change things that in the past would have been so difficult to do, but here it's just a single click. And from an analyst perspective, this is so powerful that you don't have to go back to the designer to make these changes and cause the whole development cycle to go much longer than it typically needs to go. And what it's going to show here is these changes are represented in the actual finite element analysis, and thicknesses have been changed accordingly. I'll show you that on the bottom. Amazing, amazingly powerful. I want to emphasize that Simcenter 3D is CAD agnostic. In other words, it can read in CAD data from anywhere and operate on it with synchronous technology. And it's also solver agnostic so that you can create an ANSYS deck or a Abacus deck or a Dyna deck right out of Simcenter 3D Engineering Desktop. So that could actually serve as your hub for all of your different simulation needs. Automation, I briefly spoke about this earlier with the NX Open, but we also have something called simulation templates. And what they allow is they enable a less experienced engineer to perform complex analysis tasks because these automated processes are created with templates and they're created by the experts. All the simulation knowledge that's needed for the complex analysis is built into the templates to ensure high quality simulation results that are used by less experienced users. So really, using the templates as well as NX Open, You capture the knowledge of your experts and you enable the designers or the novices to carry out routine tasks. And also, in doing, you maintain a high level of confidence. Also, what's been added into Simcenter 3D is design space exploration, which I like to call optimization, extraordinary optimization. You can optimize a part based on your particular criteria. Now, in this particular example, they're trying to minimize mass while satisfying the CAE constraints of stress or strength. In other words, you want to keep it below a certain stress values, and you pick the variables, the CAD geometry parameters that you want to change. And it's utilizing the technology that we've acquired from Sherpa and HEEDS, and it's pretty amazing. Finally, scalability. As I talked about earlier, Simcenter 3D, you can do a single part analysis, assembly level analysis, or all the way up to the high-end multi-physics. And also just to reemphasize that you can work with third-party solvers. So when you go into, you don't have to swap out your solver for Simcenter Nastran. You can continue to use ANSYS or Abacus or whatever you're used to. It just gives you a central hub for your pre and post processing. And again, scaling to extended analyses. If the designer maybe has done just a simple linear static, he can send that information over to the analyst group to extend it to perhaps do a durability analysis that enables you to have a more complete understanding of the product performance. And then finally, let's talk specifically about Simcenter 3D value. As I said, the software, hello?
Hi, Meg. Sorry to interrupt. We have a question in the chat room. I don't know if you want to make a quick stop or should we wait for the end of the presentation?
No, feel free. Let's answer the question.
Okay, yeah. Well, thank you for the presentation so far. Very interesting, the design embedded simulation concept and all of the benefits of having a good tool for design engineers to be able to do quick analysis using the wizards. But at the same time, a very powerful tool that CAE engineers or analysts can also use to do quick modifications and do different iterations. So very, very interesting. I just wanted to mention that. The question in the room, I don't know if you want to read it or should I read it for you?
No, please read it to me. I can't see it. So.
Okay, it's from Eduardo Martinez and it says, in case of an early prototype phase, where only 2 or 3 prototypes were created and you want to make sure that these 2 or 3 parts will pass all the tests, is it advisable to make the CAE analysis to the drawing coming out of a reverse engineering part? I guess the question is about, can we make a CAE analysis on reverse engineering parts?
Yeah, absolutely. Yeah, I mean, if you can extract the points, the cloud points, and pull those into NXCAD and create a solid or I forget there's a certain type of part file either in STL or convergent model. You can actually create a solid model from those points and you can reverse engineer it, and yeah, you can analyze that. So yes, that is possible. I would have to find out the exact steps for you, but yeah, that's
the points cloud is usually coming on an STL format.
Okay, there you go. Yeah.
There,
okay.
Yes, a 3D model or a solid part can be created, and using the Siemens technologies, it can also be modified in case you want to do different iterations after a CAE analysis has been
exactly.
performed.
Yeah, perfect. Yes, that is correct.
Okay, thank you. Go ahead.
Sure.
Thank you. I don't know if we have any more questions. Feel free to send it over the chat and we will try to answer them.
Yeah, I only have about 5 more minutes of stuff. Should I continue to the end?
Yes, thank you.
Great. Yeah, I just want to highlight each of these areas for you so you get a better idea of what our capabilities are. Basically, structural analysis, powered by what I said, Simcenter Nastran, which is our premier FEA solver for computational performance, accuracy, reliability, and scalability. Structural analysis solutions include linear, nonlinear, dynamic response, rotor dynamics, and durability, all of which can be applied to a number of applications to simulate structural performance, analyze vibration, ensure manufacturing processes won't break the product or the machine, and guarantee your products will last as long as you had planned. New for Simcenter Nastran is our new nonlinear capability in the form of Solution 401-402. And this was introduced a year or two ago. Dynamics. Dynamic response, key role in applications such as passenger comfort in automobiles under varying operating conditions, full range of transient frequency, random loading, and shock response. So there's a wide range of capability there. Additive manufacturing. This is new. For those of you who don't know, additive manufacturing fuses layers of metal together with tremendous heat. As the layers build up, residual heat can cause the part to distort inside the printer. This can cause various problems from structural issues with the part itself to print stoppage. And issues such as these cause many prints to fail, making getting a first-time right print very difficult. And simulation of the printing process using Simcenter 3D can alleviate many of these problems. Our solution uses a digital twin of the build tray, including parts, support structures, and residual powder to simulate the metal deposition process. And this allows manufacturers to adjust the printing process, improving the quality of the final print. It's actually pretty exciting technology. We've also introduced electromagnetics, and this set of solution allows you to carry out electromagnetic analysis for both low frequency and high frequency. Low frequency is essentially about converting energy from one form into another. For example, motors and actuators to convert electric energy into mechanical energy, or vice versa through generators. Now, high frequency is essentially about electromagnetic analyses applied in context of wave propagation. Basically, an EM wave radiated by an antenna or a cable propagating into the environment and scattered around where it is captured by an antenna, or possibly aggressing on another system, which is why you want to do the analysis. Composites. Simcenter 3D can handle the entire process of simulating laminate composite materials. Capabilities include efficient pre and post processing that include a seamless connection to FiberSim, best-in-class solvers, progressive damage growth simulation, and the manufacturing process simulation. So a wide range of capabilities here. Simcenter 3D also includes comprehensive thermal simulation that can help you to understand the thermal characteristics of your product and subsequently tailor your thermal management solution for optimal performance. CFD is another major engineering consideration. Simcenter 3D integrates comprehensive flow analysis capabilities to help you both visualize and optimize the flow characteristics of your design. Motion. Simcenter 3D offers multi-body dynamic solution capabilities that go beyond simple kinematics. Motion can calculate the reaction forces, torques, velocities, acceleration, and more for mechanical systems. Simcenter 3D also lets you directly convert CAD geometry and assembly constraints into an accurate motion model. This saves a great deal of time. It also offers a complete solution for multi-body dynamics and kinematics of analysis of rigid body mechanisms, and you can also evaluate part flexibility on mechanism performance by analyzing both elastic deformation as well as rigid body motion. And here's just an example of a motion. Now the two brackets are actually finite element models. And so what this is actually showing you is that you can do a motion model and actually do a finite element analysis inside of it and understand the flexibility and stresses in the parts, which we can do that pretty much no one else can in an integrated environment. Acoustics, we can help you minimize noise, optimize sound quality by simulating interior and exterior acoustic radiation. It includes analysis modeling tools unique to acoustics, such as creating the fluid domain geometry and/or a convex mesh. I guess the biggest application is noise radiation of machines, being engines, motors, gearboxes, essentially machines that vibrate due to applied forces, and then they radiate the noise out, which needs to be checked and minimized, and our tool can do it. So to end, the age of simulation-driven design is here, all the way from concept to allow you to discover new designs, all the way through to the detailed design, and then all the way to validation. And so you make sure that your designs actually meet your performance requirements. And that's all I had. Thank you.